Hey everyone, and welcome. Today, we are going to pull back the curtain on one of the most important rules in all of electronics. It's called Ohm's Law, and trust me, it's the secret sauce that makes almost everything with a battery or a plug actually work. So, what is this rule really? What's the hidden connection between the simple battery in your flashlight and the crazy complex circuits inside your phone? Well, we're about to find out. All right, to get a grip on electricity, which, we can't actually see, we're going to use something we can all picture, water flowing through a bunch of pipes. This one simple analogy is the absolute key to making the invisible world of electricity finally click. First up is voltage. So, I want you to imagine a big old tank of water. All that pressure at the bottom, just pushing and wanting to get out, that's your voltage. It's the electrical push that gets the whole party started in a circuit, and we measure it in volts. Okay, so if voltage is the push, then current is the actual flow. It's a measure of how much electricity is moving through the wire at any one time. In our water analogy, it's literally the amount of water gushing through the pipe. We measure this flow in amps. And finally, there's resistance. See, every circuit kind of fights back against that flow. Picture part of our pipe getting pinched and narrow. It's going to slow the water down, right? Well, that's resistance. It's the opposition or the squeeze on the flow. And we measure that in a unit called ohms. So we have our three key players: a push, which is voltage, a flow, which is current, and an opposition, which is resistance. But how do they all relate to each other? Well, this is where things get super elegant, because there's one simple magic formula that ties them all together. And there it is. V equals I times R. Voltage is simply the current multiplied by the resistance. This little equation, that's Ohm's law. It looks so simple, but it's one of the most powerful tools for understanding how electricity behaves. Now, the best part about this law is just how useful it is. It's like a little puzzle. If you know any two of the values, you can always figure out the third one. You just have to move things around a bit. Want to find the current? Easy. It's just voltage divided by resistance. Need to find the resistance? It's voltage divided by current. It's that straightforward. Okay, theory is one thing, but let's see how this actually works in the real world. We're going to take Ohm's law for a spin with a super simple, practical example. Let's start with something you've probably seen 100 times, a standard 9-volt battery. This is going to be our electrical push, our voltage source. And let's say we hook this battery up to a little component called a resistor, which provides 3 ohms of opposition to the flow. So here's the big question. With that much push and that much opposition, how much current is actually going to flow through this thing? Go on, you can probably do this one in your head. All right, let's break it down. We're looking for the current, so we'll use that rearranged formula. Current equals voltage divided by resistance. We just have to plug in our numbers. That's 9 volts divided by 3 ohms. And what does that give us? Boom, 3 amps. That is the exact amount of current flowing through our little circuit. See? Simple as that. But this isn't just about solving math problems, Have you ever wondered why, say, a light bulb on a dimmer switch can glow really bright or get super dim? Yep, Ohm's law is behind that too. You see, a bulb's brightness is all about power, and power is directly related to voltage and current. According to Ohm's law, if you crank up the voltage, the push, you're going to get more current. And more current means more power, which gives you a brighter bulb. It's a perfect real-world example of this law in action. Ohm's law is so fundamental, it even helps us classify the very materials that make up our world. Let's look at 2 opposite ends of the spectrum: conductors and insulators. So on one side, you have materials called conductors, like the copper in your wiring. They have super, super low resistance. Their whole job is to let current flow as easily as possible. But on the other side, you've got insulators, like the rubber that coats those wires. Their resistance is incredibly high, and their job is to stop the current cold, which is what keeps us safe. And all of this amazing foundational knowledge comes from the work of one man, a German physicist named George Ohm. His discovery wasn't just some neat idea, it literally became the bedrock of all modern electrical engineering. Wow, okay, we've gone through a lot here, from pipes and water to batteries and light bulbs. So if you're going to remember just one thing from all this, what should it be? What's the big takeaway? It all boils down to this simple phrase: voltage pushes, current flows, and resistance opposes. If you can remember that, you've got the core concept down. These 3 ideas are in a constant dance,
and Ohm's law is the music they dance to.
Honestly, learning this simple rule is like learning the alphabet of electricity. It unlocks the door to understanding pretty much every circuit you'll ever come across. So the real question isn't just what you learned today, but now that you know the rule, what will you go on to understand next?